So we were doing the problem on the spiral reinforcement അല്ലെങ്കിൽ helical reinforcement. Okay, so we can start now. അപ്പം നമ്മൾ we are doing so where we reached, we are studying about the helical reinforcement of a column. Okay, so helical reinforcement of a column. So എവിടെ എത്തിയത് നമ്മൾ we have find out the okay helical reinforcement. First of all we have find out the core diameter. Like core diameter we have find out area of the core, we have find out. Next is volume of the core in one pitch. Okay, so next is you have to find out the volume of core in one pitch, or we can say per pitch. ഒരു പിച്ചിലുള്ള വോളിയം എത്ര എന്നുള്ളത്. ഓക്കെ, സോ ഏരിയ ഓഫ് വൺ കോർ we know how much is the area of 1 second. So area of the core is equal to how much it is? Area of the core is equal to 6880.8 mm square. We have assumed the pitch as P. Okay, we have assumed the pitch as P. അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ how much is the, okay, if this is the reinforcement, so this is how helical reinforcement we are providing. Okay, ഇങ്ങനെയാണ് helical reinforcement കൊടുക്കുന്നത്. So this is taken as one pitch. Okay, so next is you have to find out the volume of core in one pitch. ഈ ഒരു പിച്ചിലുള്ള കോറിന്റെ വോളിയം. So volume means basically what? Area into height. Area into height. Okay, so here we can take as, okay, so volume of core in one pitch. Okay, so that is equal to 6880.8 into P. Okay, so that is volume of core in one pitch. Second is you have to find out the volume of spiral in one pitch. Okay, അപ്പോൾ രണ്ടാമത്തെ കേസിൽ ഈ ഒരൊറ്റ പിച്ചിലുള്ള ഈ സ്പൈറൽ റീൻഫോഴ്സ്മെന്റിന്റെ വോളിയം. Understand? First we have find out volume of the core, അതായത് അവിടെയുള്ള concrete area, how much of concrete area ന്റെ volume we have find out. And secondly, in a one pitch how much is the volume of spiral reinforcement നമ്മൾ ഈ പ്രൊവൈഡ് ചെയ്തിട്ടില്ല. This is a spiral reinforcement. Okay, so this is a spiral reinforcement that we have provided. Okay, so volume of the spiral reinforcement in one pitch, that's something next you have to find out. Okay, so volume of the spiral in one pitch. Okay, so how much it is? Okay, so how much is the what is the diameter of the spiral? Okay, so for example we don't know how much is the diameter of the spiral, so we can take it as, assume it as, so we are assuming the spiral as 8 mm dia. Okay, assuming the spiral as 8 mm dia. Okay, so how much it will be? Any guesses? Any guesses? Can anybody make a guess? Okay, I'll tell you. So we have assumed the 8 mm dia spiral വെച്ചിട്ട് volume of a spiral in one pitch is equal to pi by 4 into d square, that is area of the spiral. Okay, area of the spiral. Okay, area of the spiral. Okay, so ശരിക്കും ഈ സ്പൈറൽ എങ്ങനെയാണ് ഉള്ളത്? Okay, this is like this, ഇങ്ങനെ റൗണ്ടിലാണ് the spiral, ഇങ്ങനെ വട്ടത്തിൽ. This is how it is. Like this is the main reinforcement. Okay, this rounded portion, this is the longitudinal reinforcement, that is 20 mm dia. ഈ വട്ടത്തിൽ കാണിക്കുന്ന, okay, this round portion is your 8 mm dia. Okay, this is കുറച്ച് confusing ആണ്. Understand it properly. Okay, so this round portion is your spiral. Okay, so ഈ ഒരു round portion ന്റെ volume you have to find out. Okay, if you take a plan, you can see that this is actually round in shape. This spirally tied. Spiral is tied in the sense they are helically tied to the longitudinal reinforcement. Okay, so that volume is equal to pi by 4 into d square into how much? The circumference. Circumference is pi into 300 minus 8. Okay, so 300 means what? That is the core diameter. 300 means that is the core diameter. Okay, the 300 is the core diameter. 300 is the core diameter. A core diameter, you have to minus the outer ആയിട്ടുള്ള ഇത് circumference you have to take. Okay, circumference you have to take. Okay, so for that from the 300 you have to minus the diameter of the spiral. Okay, into, so you will get the circumference. Okay, so that is pi by 4 into d square, that is the area of one spiral into circumference. So circumference is pi d. Okay, circumference is pi d. Pi d alla circumference പറഞ്ഞാൽ. Okay, so pi into d means what? Okay, that is 300, the core diameter in ഈ ഒരു ഇത് മൈനസ് ചെയ്യുക, that is reduce the diameter of the spiral, so that inside portion, that inside portion. Okay, so you will get the volume of spiral in one pitch. Okay, so this is the volume of spiral in one pitch. So how much it will be? Okay, so you will get this around 2411 0.8 mm square. Are you getting this? Two pi r, that is in terms of r. Okay, 2 pi, okay, ഞാൻ മെസ്സേജ് കണ്ടിട്ടില്ല. 2 pi r എന്ന് പറയുമ്പോൾ 6 ടേംസിൽ, ഞാൻ ഇത് wrote this in the terms of diameter d. Okay, 2 pi r, that is in the terms of radius. Okay, this I have wrote in the terms of diameter 2 pi d. Okay, 2 pi r എന്ന് പറയുമ്പോൾ that is in terms of radius ആയിരിക്കും. This is in terms of diameter. Okay, okay, so that is it. So volume of spiral in one pitch. Okay, okay, so we have got it. Next is we are going to IS 456. Okay, take your IS 456. Hello, IS 450. So before starting the question, so before starting the problem, I have asked you to refer IS code page number 71. In that they have mentioned about the spherical ties. So what they have mentioned? All of you take your IS score first. Page number 71. Take it. So see, page number 71. See, close 39.4. Okay, so this is it. Close 39.4. They have mentioned about the compression members which is having a helical ties. Okay, so the first one is that when you're having a helical tie, the strength will be 1.05 times greater. Okay, for that condition we have used. Second condition is that the ratio of volume of the helical reinforcement, okay, to the volume of the to the volume of the core shall not be less than 0.36 ag divided by ac minus 1 fck divided by fi. Okay, so next is that you are going to use this condition to find out the pitch of the helical reinforcement. Okay, so ഈ ഒരു condition വെച്ചിട്ട് using this condition you are going to find out the pitch of the helical reinforcement. Okay, so let's see how you are doing it. Okay, so you have already find out the parameters. Okay, so write down. So volume of the helical reinforcement volume of the helical reinforcement divided by volume of the core. Okay, that is as per the IS 456. Okay, IS 456, page number 71, close 39.4. Okay, so it should be less than or equal to 0.36 AG divided by AC minus, okay, minus 1, okay, into FCK divided by Fy. Okay, into FCK divided by Fy. Now let's substitute it. Volume of the helical reinforcement, how much it is? We have find it out. That is for one, we have taken it for one pitch. Okay, we have taken it for one pitch. One pitch in the case on okay, so 4 6 double 1 0.8. 0.8 divided by volume of the core. How much we got it at? We have got it as 68808 68801. Okay, 01.8 p should be less than 0.36 into ag. How much is the ag? Area of the core, sorry, area of gross section, that is 125,663. 663.7 divided by area of the core area of the core, that is 68801.8 minus 1. FCK is 25. Fy in 415. So just so using this equation you can find out P. Okay, so this is the condition that is mentioning in the IS 456. So using this condition you can find out the unknown, that is P. Okay, but unknown I do the P. Okay, you can find out the value of P. Okay, so if you solve this equation you will get P approximately as P will be something like 37 കിട്ടുന്നുണ്ടോ? Are you getting it? So the P will be approximately 2.30. If you solve this equation, you will get around 37 value. Are you getting it? Fast. Okay, just check it. You will get the value around 37. Okay, so that is as per this equation we have got that we can take a P ranging to 37 mm. Okay, so ഇത് confirm ചെയ്യാനായിട്ടില്ല. You have to again check the criteria with the IS 456. IS code or maximum pitch etra, minimum pitch etra, that all we have to check, then only we can provide it. Okay, okay. So let's again go back to IS 456. Okay, IS 456 ലേക്ക് തിരിച്ചു പോയി കഴിഞ്ഞാൽ they have mentioned about the conditions. Okay, wait. So 1 second. Okay, so you can refer page number 41, 49, the same page. The same page, you can refer the page number 49. Okay, so see here. See. IS code page number 41. Okay, the same page we are referring for the lateral ties also. Okay, this same page in you are referring for the lateral ties, so there is no difference. Lateral ties in a diameter at the same time for the spacing. Okay, okay, you are referring the same page. So for helical reinforcement also you can refer the same page. Okay, so here they have mentioned IS code page number 49. Okay, they have mentioned about the helical reinforcement. Okay, how to provide a helical reinforcement. See the pitch അതേപോലെ തന്നെ diameter. Okay, so diameter of the helical reinforcement shall be in accordance to 26.5.3.2. that is similar to lateral ties. നമ്മൾ നേരത്തെ lateral ties എങ്ങനെ കൊടുത്തോ ആ same way തന്നെ you can provide the diameter for the helical reinforcement. Okay, so that we have assumed 8 mm diameter. Okay, so there is no issue in that. Second one is coming to the helical reinforcement, that is pitch. Okay, so the pitch അവർ പറയുന്നത് see. So where the increased load on the helical reinforcement, the pitch of the helical turn shall not be more than 75 mm. Okay, pitch of the helical turn shall not be more than 75 mm, not more than 1/6 of the core diameter of the column, nor less than 25 mm, or nor less than 3 times of the diameter of the steel bar forming the helix. Okay. In other cases, the requirements of 26.3.2 shall be complied with. Okay. So this is the condition that is referring to the helical reinforcement. Okay. That's a condition. Helical turns shall not be more than 75 mm, not more than 1/6 of the core die of the column, nor less than 25 or nor less than 3 times of the diameter of the steel bar forming the helix. Okay, so just go through this. Okay, so anyway, you can write this. So helical reinforcement. So helical reinforcement, that is equal to, they have mentioned about the maximum pitch and minimum pitch. Okay, they have mentioned about the maximum pitch and the minimum pitch. Okay, so for the maximum pitch they have referred like, okay, so maximum pitch അവർ refer ചെയ്തത് it shall not be more than എത്രയാണ് 75, it shall not be more than 75 mm. Okay, 75 mm ൽ കൂടാൻ പാടില്ല. Okay, it shall not be more than 75 mm, or core diameter of core dia divided by 6. Okay, or core dia divided, this is core dia. Okay, or core dia divided by 6. So how much it is? Core dia is 300. 300 divided by 6, that is around 50 mm. Okay, now coming to the minimum pitch. Okay, at the same time they have also referred that it should not be less than certain value, minimum pitch. Okay, so the minimum pitch should be 25 mm. Second one, 3 times diameter of the helical turns. Okay, 3 times dia of the helix turns, that is equal to 3 into 8, that is 24 mm. Okay, അപ്പം ഇതാണ് അതിൻ്റെ റേഞ്ച്. Okay, that is minimum ഒരു 25 എങ്കിലും we have to provide at the maximum of 75 അല്ലെങ്കിൽ core dia divided by 6. Okay, so this is the range of the pitch. Okay, so what we have got, the value is around 37. Okay, so you can round that 37 value to 38. Okay, the pitch, that 37, we can round it to 40 mm, അതായത് 4 centimeter. Okay, so provide a pitch of 8 mm, so provide a pitch of 40 mm for 8 mm dia spirals. Okay, so write the note as, so 40 is safe, right? Okay, it is satisfying all the conditions. Okay, it is not exceeding the maximum value, or it is not the least value also. Okay, so we can go with the 40 mm, what we have got is correct. Okay, so you can write down the note that provide 40 mm as the pitch for 8 mm dia spirals. Okay, now we can go to the reinforcement details. Next is we have to go to the reinforcement details. And one more thing, I have checked your assignments. കുറേ പേരൊന്നും അസൈൻമെന്റ് കംപ്ലീറ്റ് ചെയ്തിട്ടില്ല, ഇൻകംപ്ലീറ്റ് അസൈൻമെന്റ് ആണ്. കറസ്പോണ്ടിംഗ്ലി ഐ ഹാവ് റെഡ്യൂസ്ഡ് മാർക്സ്. കുറച്ച് പേര് പകുതി എഴുതിയിട്ട് ഡൗൺലോഡ് അപ്ലോഡ് ചെയ്തിട്ടുണ്ട്. ആൻഡ് സം പീപ്പിൾ ഹാവ് നോട്ട് drawn the reinforcement details also, which is a mass mistake. Okay, so for university you will be having 2 marks for the reinforcement details. Okay, so please draw and study the reinforcement details. Okay, so you have to draw 2, that is one a longitudinal section and one cross section. Okay, so this is the reinforcement details. So this is the longitudinal reinforcement. So this longitudinal reinforcement, this is 20 mm dia. 6 numbers of 20 mm dia. Okay, you can hashtag, this hashtag indicates numbers of. Okay, so 6 numbers of 20 mm dia bars. So next is helical turns. this is how the helical turns will be. Okay, helical turns in the, so this is 8 dia spiral ties, which is having a pitch of, okay, so this is having a pitch of 40 which is having a pitch of 40 okay. So next we can go to the dimensions. So dimension is, how much it is? Diameter of the column is 400. Okay, core dia will be 300. Okay, cover, okay, even though we are not used to cover anywhere, you have to mention the cover. Okay, I think we have used the cover to find out the core diameter, right? So cover we have provided as 50. Okay, so 50 cover, so this is the cover, 50 cover. Okay, so this distance is your 50 cover. Okay, so we have drawn all the details. So this is a longitudinal section. Now you have to draw the cross. Okay, one, 2, 3, 4, 5. 1, 2, 3, 4, 5 and 6 numbers. Okay, so 6 numbers on a 6 hashtag 20 dia bars diameter. TMM. Spirals, and here it is the core dia. Okay, so you have to draw these two reinforcement details. Spirals, I can mention the pitch also. Okay, at 40 center to center. Here also you can mention at 40 center to center. Okay, so this is the reinforcement details. Okay, so always remember main diameter spiral tights. Okay, so you can use it for the column. You can take it from 6, 8, 10, 12. That's it. Okay, error. That is the high columns. Large columns you will be using large ties. Okay, so is it done? Okay. Okay, so this is the reinforcement details. So that is why we have completed the column with the helical reinforcement. Very small problem. Next, we are going to the next column, that is column with the axial loading. Okay, column with the uniaxial loading. Okay, so this is the column that right now we have completed. This is how it will be. Okay, spiral ties അതിന്റെ longitudinal section, cross sectional view. Okay, top view. Okay, next is we are going to study about a column which is subjected to axial compression and bending. Okay, column which is subjected to axial compression and bending. Okay, so for the tutorial class I have already shown you the different types of loading that is occurring on the column. Okay, that is, there will be a load that will be passing to CG. At the same time there will be also a load which is having eccentricity, center in the മാറിയിട്ട് also എവിടെയായിരിക്കും രണ്ട് ആക്സിസിന്റെ നടുക്കായിട്ടും ലോഡ് ആക്ട് ചെയ്യും. Okay, so these, apart from the axial load, the other two loading will be creating a bending effect. Okay, other two loading will be creating a small bending effect. Okay, so adina, if the bending is coming in the column, how to deal it? Okay, so see this. Okay, these are the different position. Okay, so the first one you can see here, this is the axial load with the uniaxial bending. That means in this is the first one, this we have completed. Okay, okay, we have completed. Right now we have done this type of column. Okay, next we have completed this type of column. Next is you have to study this one and this one. Okay, so second case, what is happening, axial load on but uniaxial bending. Okay, so you can see here the column, the load is acting over here, that is away from the CG till it is acting on the axis. Okay, away from the CG, the load is acting away from the CG, but still it is acting on the axis. Okay, so that is an axial load which will be having a uniaxial bending. That means bending will be in one direction. Coming to the second one, you can see here that the load is not acting on any kind of axis, and since it is having a biaxial bending, see central ആയിട്ടാണ് വരുന്നത്. Okay, രണ്ട് ആക്സിസിന്റെയും ഇപ്പുറത്തായിട്ടാണ് വരുന്നത്. Okay, so we can see that we can tell that here biaxial bending, that is in both the direction, in this direction, you can see in this direction and this direction bending will be occurring. Okay, so how to solve these kind of columns? So this kind of columns cannot be solved using IS 456. Okay, so here you have to use SP60. Okay, in such problems you have to use SP16. Okay, so see here, different position of axial forces from the section centroid produces various behaviors of column as well as stress distribution in the section. These are plotted on MN interaction curve. Okay, that is moment to axial load. Okay, so different, based on the position of the axial force, the column will be behaving in different way, and at the same time there will be a stress distribution in a different way. So based on this we are having a graph like this. Okay, we are having a graph like this. The graph, on the x-axis you are having moment capacities, and on the y-axis you are having axial load capacities. Okay, so from this graph is already plotted. That means the scientists have already plotted this graph. Okay, so using this graph you have to solve the columns. Okay, so this graph is available in the SP60. Okay, e graph vechitana next you have to find out, next you have to design the columns in case of uniaxial and biaxial bending. Okay, so let's see what is this graph. Okay, so this is a graph which has plotted, അതായത് നമ്മുടെ ആ രണ്ട് uniaxial bendingum biaxial bendingum വരുന്ന കേസുകളിൽ they have plotted this graph. That is, they have plotted the moment against load കൂടുന്നതിനനുസരിച്ച് എങ്ങനെയാണ് moment വരുന്നത്. Okay, so they have plotted the graph like load versus moment, that is axial capacities of the column versus the moment capacities. Okay, so this is there will be a curve like this. You will get a curve like this. Okay, so this curve is divided into different sections A, B, C, D, E, F and G. Okay, so over point lo, okay, the column will be behaving in a different way. Okay, so coming to the first one, that is pure axial compression, that is at the point A. Okay, so at the point A, the largest axial compressive load that the column can support. Okay, so this is the point A. Okay, ഈ point A ല് Okay, this is the largest load that the column can support. We can see from the figure itself, right? Alle? Load value to highest, this is the load. Okay, so for any given moment, this is the highest load. Okay, so maximum load you will be getting at the point A. So point A indicate the maximum load that a column can take. അല്ലേ വേറെ ബാക്കി if you see the point B, column load is low over here. Column C, sorry, not column C, at the point C load is less. Okay, so at the A point we are having the highest load. Next is coming to the, okay, okay, I can first name to mark the attendance now.